So picking up where we left off with multiplying matrices, when we're talking about the general structure of matrix multiplication, we're talking in terms of combinations of rows and columns, where if you take a more general product than just 2 by 2, the pattern more or less holds that what you get in slot ij from the product comes from the ith row of the first and the jth column of the second. Where when we're talking about multiplying matrices, we have a few main properties that we work with, where we have that if you take 3 multiplied together, you can essentially regroup them. That A, B, C is equal to A times BC. Also, you have distribution. A times B plus C is equal to AB plus AC. And for constants, you have that same sort of grouping idea that C times AB is equal to CA times B. But there's one very important property in here that you don't generally get. That is, it's very rare that with matrix multiplication, we have that AB is equal to BA. There are some really important cases where this happens, and in the next section, we'll talk about a couple of them in particular. But usually, this is very much not the case. You do not get what's called the commutative property for matrices in general, and in fact, it's very rare that it happens. And to understand this, as well as maybe get a little bit more intuition for how matrix multiplication works, we'll take another example, but as we're working on it, I'm going to try and reframe it a little bit to maybe clarify how this structure comes together.